mic for you.
Thanks, Anton, and good evening, ladies and gentlemen. A brief about myself. I'm Abhi. I have more than 10 years now of work experience in the software testing. I started my career with a company named Infosys, followed by a few years as a technology consultant with PricewaterhouseCoopers. Last couple of years, I worked for Emirates Airlines, and currently I'm on a career break for the last couple of months, enjoying my long vacation and soon to join my new workplace. So, thanks, Anton, for giving me this opportunity for sharing my experience with working with this topic, specifically around the contract testing for the Polyglot Microservices. I had been working with this one for nearly a year, and I thought that this could be the right topic to share with all of us here.
Yeah,
All right.
that's great.
Can anyone just confirm that my screen is visible?
Yeah, screen is visible. I just want to mention that we already had one presentation regarding the contract testing. That's why you can compare it, check our records on YouTube, and I think it's also good to get like brighter description about this. Thanks.
Thanks, Anton. I think when I spoke to you, I also went through that presentation, and that was more around the Spring Cloud contract as a tool for contract testing. That's one flavor and one widely accepted way of doing the contract testing. And today I thought of discussing with the another way, which is more popular, also very popular, with the PACT way, the way the PACT is used as a framework for contract testing. So to start with, we have the topic that I'm going to discuss here today is the contract testing in Polyglot Microservices. So I would be going through the topics like the microservice, just a brief introduction to it, what it means by the word polyglot, and then the contract testing, and followed by how PACT deals with the way the contract testing is done, and how PACT helps us in addressing the polyglot microservice problems, and then followed by just an indicative pipeline representation that might be a reference for how we can use these tools or this entire framework for our continuous testing. So starting with the microservice architecture, a very popular term recently, most of the enterprises are moving towards the more microservice from the monolithic architecture, which was the classic older way of doing things. By definition, microservice architecture is basically a service-oriented architecture composed of loosely coupled elements that have bounded context. In easier words, it's more of dividing the entire business functionalities of an enterprise into the smaller chunks of services, which deals with one specific set of problems. So one specific enterprise, if it is an e-commerce enterprise, it might have a shopping cart, it might have an order, it might have a payment, it might have the delivery, and a lot of other functionalities on the business functions. Whereas the older monolithic way, we used to deal with all this different set of functionalities under a single was monolithic architecture with the different service endpoints, whereas in case of the microservice architecture, each of these business functionalities work as separate entities, and all of this together form this entire microservice environment in which the entire application works. Now, although it might sound like it's just a bunch of services that work together, but in the true sense of microservice architecture, deals with a lot of other things apart from just being a bunch of microservices. There are the application infrastructure patterns, which determines the security concerns and other different application infrastructure related things. There are things like the I mean, the way it works for the communication patterns like the communication styles, what are the different inter-process communication mechanisms that you should be using. It also deals with the discovery, like for a specific client service, client call, how service determines the IP address of a specific service instance so that it can make an HTTP request. It also deals with the reliability part of it, the transactional messaging, also how to deal with the different external API communications. This all falls under the communication patterns. Then there are the data consistency patterns for the data transaction management, then querying the data, and implementing the CQRS patterns, which is known as the command query responsibility segregation. That is the data creation and data querying happens from a completely different responsibilities and do not happen uh, in an overlapping way. So these are the different aspects or the elements of a microservice architecture, which in turn adds on a lot of complexity. And like any other system, it also needs a lot of observability so that you can identify what is going wrong and where the system is behaving properly and where it is not. Although this microservice architecture adds a huge benefit on us by for testing the individual services, because those are really small in size, and it deals with the specific business functionalities which are much smaller and very easy to test, because the business functionalities and the scope of the testing is very limited. However, it's very important, and one of the most important aspect of the microservice testing is how it works in an integrated environment when the different services are working together. And the long running integration tests might be slow, it might be complex, and the tests could be brittle. So it's a real challenge that how do we address those specific issues. And at the same point in time, we deal with a specific pattern where all the microservices individually and together works properly and is testable. So the next term is the polyglot. We are talking about the polyglot microservices here. This is just an excerpt that I took from one of the paper, which is called as the Polyglot Programming, a Business Perspective. It says that polyglot programming is the activity of programming in more than one language within the same context, much like humans use different language to make the expressions more effective. The goal of polyglot programming is to render simpler solutions by combining the best solutions from different programming languages. So when we started with our own microservice architecture, the most of our microservices were getting designed using Java Spring Boot, because those were the popular among the developers, and those were the one set of things that were getting developed. But slowly and gradually, we started realizing that some of the features or the other are basically works better with the other programming languages. Like if you are dealing with a big data, maybe Scala plays a better role, or a Python for any kind of data engineering related services, and that's how it works. So we started introducing the new programming languages into our microservice architecture, where we could use the different programming languages for our designing the different microservices. So although the different microservices are getting designed using the different programming languages, we still are using the same architecture, the same infrastructure. We are utilizing the same messaging queue. We are utilizing still the same service discovery and the same testing pattern. So our continuous integration and continuous deployment pipelines are separate, but we are still using I mean, although those are separate, but we need to have a very common testing pattern among each one of those, so that it actually solves the bigger problem, and we are able to understand and see that how the testing is happening across the different systems. Now, the next thing that comes, and a very popular type of testing lately, is the consumer-driven contract testing. So the consumer-driven contract testing is more of, first of all, what is contract? A contract is basically an agreement between a service provider and a consumer. So if I am providing a service to anything, so I'm bounded by some set of agreements between with my consumer, and that's what the contract is. Contract testing is the process of testing that specific contract. Now, in terms of our microservice architecture, a contract is basically the communication between my producer and the consumer, and the contract testing is basically ensuring that the promises that has been made by the provider to our consumers are actually met on the provider side while the service is getting actually developed. So it's a validation against the actual code implementation. Now, a contract can be of two types. One is a provider, one is a provider contract, and one is a consumer contract. So a consumer contract, a provider contract is basically a contract that has been provided by the producer of the service. That is the provider is giving me a set of documentation that talks about how my different communication is going to work. So uh, for example, a Open API specification is a classic example of a provider contract, where you get to see that what are the different fields in a response, what are the for a REST service, so what are the different request fields, and what is the method exactly you are making requests with. Now, a consumer contract or a consumer-driven contract testing is just the opposite of a provider-driven one. So provider-driven contracts are authoritative. So it deals and talks about how exactly it is designed, and it's the responsibility of consumers to validate that it is abiding by the provider side. So at times it's another way of doing a contract testing by the provider-driven way. Lately, it has been very popular. I have been in touch with many contributors in the PACT framework, and they have been working on how the provider-driven frameworks could be used for leverage for the contract testings, because the consumer-driven ones have some complexity in it itself. So the point we are going to discuss today is more around the consumer-driven contract testing and the consumer-driven contracts. Basically, it's the approach of accounting the consumer expectations regarding the schemas that exposed while evolving the provider service, and more essentially that provider knows about them. So which essentially means is that I am a consumer of a service, and there is a producer service, and that producer service exactly knows that what I'm expecting, because a service as a provider makes sense. So or is responsible for only those things which a consumer is actually consuming. So I might be exposing 100 different fields, but my consumers are only concerned about 5 different fields. So essentially, I can get rid of the other 95, but I still need to be on those 5. So consumer contracts are very important in the context when it comes to the knowledge of the provider knowing that how my consumers are behaving. Now, the consumer-driven contracts are basically the specific consumers providing all set of interactions that happen with the different providers, and they're taking out all the information and sharing with the provider for their validation on their side. So some of the advantages of consumer-driven contracts are those are close and complete. So a consumer-driven contracts are basically a consolidation of all the different interactions that happen between a provider and a consumer. So all those taken together is basically what a consumer expects out of a provider. So a consumer-driven contract is basically close and complete. It's singular because it's a consolidation or the aggregation of the different consumer contracts, and it's a single document, so it's singular, and it's non-authoritative because it does not dictate how my provider behaves. It just dictates the way provider and the consumer interacts. And every contract, consumer driven contract testings are consumer bounded. That is, a consumer driven contract is only valid for a specific consumer, and it's immutable till the time the consumer changes its code. So now that was more about the topic on how the what do we mean about the polyglot microservices and what it is about the contract testing. And now I will be going to the next part of it, which is the pact way of doing it. So before I go into this one, there are two of the most popular tools. Although apart from that, I found there are a few others as well. The most popular ones are the Spring Cloud Contract and the Pact. And I would also like to share my journey with the contract testing. When we started, we initially started looking for the Spring Cloud Contract because because at that point in time, our microservice environment was not a polyglot. It was more of a Spring Boot microservices, and the Spring Cloud contract was working perfectly with that. But as soon as we started adding up new programming languages, we started realizing that uh, that Spring Cloud contract might not be the best tool to go for it, and we started to look for something which is language agnostic and could work with more than one programming languages. And that's when we started looking for the pact. The Spring Cloud contract also has the support for the polyglot. You can create a stub runner and run a stub runner on a Docker, and in that way, something that doesn't fall into uh, the uh, the Spring Java world or outside of JPM, you can still access or leverage the benefits that is exposed by the stubs created by the Spring Cloud contract. However, you need to keep one thing in mind is that while you set it up, you need to have your Docker containerized implementation of the stub runner, and it has to run in parallel. And that might add some complexity to your test execution. So, although there are things like the test containers which can help you with that one, but again, that's an overhead that you need to take. And that's when the pact came handy, because when we started looking into pact, and we found that pact has the support for more than 10 programming languages, and essentially covering almost all the popular ones, including Java, .NET, JavaScript, Scala, Ruby, Python, Go, and also probably it has support for Kotlin as well. So it has support for several programming languages, and that's when we started looking for the pact. So first, I would just take you through that how it works in pact. So it's my understanding that for working in pact, it's a 6-step process. The first step is defining your interactions. So every time a consumer contract, each interaction is basically a consumer contract. So a consumer says that when I send this request, I'm expecting this response to come back. That is an interaction, and that interaction is open and incomplete. When we combine all the interactions together, it becomes closed and complete for a specific consumer. So the first step is defining the interactions. Second step is writing the consumer tests. So the consumer tests are it's a little different approach to Spring Cloud Contract, where in case of Spring Cloud Contract, we used to write the contract itself and tests were automatically derived. Here, the contract is auto-derived out of the consumer tests that we write. So here on the consumer code base, we are going to write our consumer tests. And these consumer tests execute the consumer functional behavior. These tests are primarily focused around the interaction with the provider. So the interactions that we have defined in step 1 are basically going to get used in writing the tests, or in the tests that we are writing in step 2. Now, when we come to this next step, which is validating the consumer tests, it's more around the executing the tests. Now, when these tests get executed, the pack spins up a mock server, and all the interactions work as a stub, and the tests are executed against the stub. So when your test gets executed, it actually goes via these stubs and actually make sure that your consumer functions work properly. That's all about validating the consumer tests. The next thing is verifying the pact. So you might have 50 different interactions and you execute all your tests. The verified pact actually ensures that all the different interactions or all the interactions that we have written have been executed, all the tests are passing, and also it verifies that all the interactions are actually covered by some of the consumer tests that we have written. So it's more strict in nature. So we cannot have any interaction without a test, or or the reverse way is possible, but we cannot have any interaction that does not have a test. Then in that case, the step 4 is going to fail, complaining that you might have had 50 different interactions, your tests executed 49, but one specific interaction was not executed by any test. So it will start complaining about this one. The next part is publishing the pact. So once you get successfully executing all your interactions through some of the consumer tests, then a pact is getting published. So pact is nothing but a specification. It's more of mostly written in JSON. It's a JSON file, and that file gets automatically generated, aggregating the different interactions that we write. So pact framework, the pact JVM, or if we are using pact JavaScript or pact on Ruby or anything like that, everything, all of those, when tests get executed and pact gets verified, it automatically creates a pact file, and that pact file gets stored in your local repository where the tests are executed. Now you can publish this pact because it's all till this point, till the point 4, everything is happening on the consumer side. And the contract testing is something that needs to be done on both the provider and the consumer side. So you need to publish this pact files somewhere from where the provider will be getting all this information, where the pact community has come up with another application which they call as a pact broker. It's a containerized application which you can have your own instance implemented, or there is a software as service as well, and you can go for that one as well. And by executing some CLIs or some plugins in case of Java, you can publish all those packs to this pact broker, as they call it. So as soon as you push all your pack to the pact brokers, then the provider can get all this pact or the consumer contracts from the pact broker, and on the provider side, they can fetch for a specific provider all the consolidation of the different consumer contracts, and they can get everything uh, on the provider side and run all the tests and validate the providers. So although it's not my goal to compare between the two tools here, the Spring Cloud contract and the pact, but just from my knowledge, in case of our consumer contracts in the there is all the consumer contracts are actually kept in the pact broker and not on the provider side, and that is also auto-generated contract that comes from the different tests that get executed on the consumer side. Now, okay, to this point, it's all right that we have the pact and it's a different way of working with pact, but the question that still remains is that how did it help us addressing the problem of polyglot? So here I just try to give sort of an example that specifically talks about a hypothetical situation and how the different programming languages come into picture in a polyglot, and how pact helps us in solving this problem. So here, maybe in this microservice architecture, we have 5 different services and 3 different programming languages used. Some of the microservices are written in Java, some has been written in JavaScript, some has been written in Python as well. So just to give I mean some idea about how I have written this one is that microservice A is consumed by microservice D, and microservice A is a consumer to microservice B. So if we look at microservice A, it's both a producer and a consumer. It's a consumer of microservice B, and it's a producer of microservice D. Similarly, when it comes to microservice B, it's a consumer of microservice A and E, and it's a producer to microservice A and E, and it's a consumer to microservice C. Now, if we see, so let's take the example of microservice B and how it is solving the different problems. So, uh, if we see, we have two different consumers here. One for microservice B, one is written in Java, and the other one is written in JavaScript. So all these microservices in our architecture, let's consider all those are pact compliant. So all of them are using pact as a framework. So what it does is that the microservice A writes its consumer interactions and the consumer tests in Java, whereas the microservice E writes all its interactions and all its consumer tests using using JavaScript and Pact. Now, when they do the pact verify, all these tests get executed, and once the tests get executed, the packs get generated, and those packs are pushed by both these microservices to the pact broker. Now, when it comes to the microservice B, it doesn't matter whether it is written in Java or JavaScript. It just writes a script to pull all its consumer microservice consumer contracts from the pact broker and validates on the producer side. So even when all the participating microservices here falls into different programming languages, we were still able to solve the problem with Pact, still keeping all the tests native to the programming language the way the microservices are written. Because in a CI world, it's very important to keep the tests native to the programming languages in which the services are being written. That encourages more developers to contribute towards the automation testing. It helps in maintenance of the tests in the longer run. So that's where Pact was immensely helpful for us when we started addressing the polyglot. So going next to the pact broker is so as I was mentioning that the pact broker is basically an application for sharing the pact contracts and the different verification results between the services. So we have a number of so it's basically we might have the 50 different consumers for a specific microservice, and then all these consumers can write their contracts and push their pacts to the pact broker. And when the provider validates everything, they can also validate push their verification results back to the pact broker. So pact broker works as a consolidation for both the or as a consolidation of the all the consumer contracts and the different consumer verification results. So at any point in time, it's very good visualization, and it shows through a network diagram that how the different provider and the consumers are interacting. It also gives you a good visualization of where it exactly stands in terms of the compatibility between my producer services and the consumer services. It runs on Docker, so you can get your registry from the Docker Hub and get the latest image and run your own instance on Docker. Otherwise, there is now an option for the Pact Flow, which is a hosted version, and it's a software as a service where you can go and directly push your test results. And uh, Pact Flow is coming up with a lot of new features which are not available on the open source version of it, but both comes handy in terms of the CI/CD integration while we are doing the basic things. Then the packs can be published and retrieved by both the CLI and the HTTP request. So it can be it can go by the REST post methods, or you can use a command line interface for publishing the pacts back to the pact broker. It also exposes a lot of webhooks, and these webhooks are really important when you are doing a CI/CD integration, because it helps to trigger the HTTP requests on certain events. So, for example, on the consumer, a consumer is making certain changes, and it changes on the consumer contract, and the contract gets published. So as soon as and when the pact gets published to the pact broker, it triggers an event that pact has been changed or a new pact has been published, and immediately that can trigger a pipeline on the provider side to make sure that this new pact which has been published is actually compatible with the provider. And this verification is really, really important if you want to have a seamless deployment, and you want to really protect your application uh, from breaking some features or the other. And then comes another CLI with pact broker, which is the can I deploy. So the can I deploy is another interesting thing, which takes a provider and a consumers, or rather a provider, and if you are trying to, or it might take a consumer as well. So if you are, for example, if we go back to our previous example, so if I try to promote the microservice B to a specific environment, or I want to deploy microservice B, the can I deploy, what it does is that it goes back and checks the contracts of microservice A and E and the verification status. So for example, if there is a very useful microservice which has maybe 50 different consumers, it's difficult for you to know that when all my consumers are compatible before promoting my provider service. So as soon as I run the can I deploy, it actually goes back to the pact broker, takes the verification results and the versions, and compares that all the provider versions are compatible with all the provider version that I'm going to deploy is compatible with all the consumer versions. So as soon as everything is green, the can I deploy shows your success, and you can go ahead and deploy. And in case any of my consumer is still breaking, it will stop you from deploying to a specific environment. If used wisely and in a very disciplined way, this can come really handy in even doing seamless deployment to the higher environments, even up to production. So it can any point in time give you a snapshot of where it exactly stands. If I have 50 different consumers, how many are compatible, and if it is a breaking change, that how many am I going to break when I go to production, and then you can rectify the problems and start resolving the issues, and then have a seamless deployment. The next is just a couple of snapshots of the code. I have taken all this code snaps from the pack documentation. Nothing fancy here. I just wanted to show the two flavors of it. One is a Spring Boot flavor, and the another one is a JavaScript flavor. Is it visible? I can try to zoom it.
Yeah, it's
So yeah,
visible.
okay. So if we see in the Spring Boot, so as we define that it's a 6-step process. First is defining the interaction. So if you see here, this pact at pact annotation is basically says about a consumer, and this is basically where we are defining a specific interaction. So we are saying that upon receiving a specific request on this path with a method get, then we are expecting a JSON body of we are expecting a status code of 200 and body like this. And this specific thing, this body is the JSON pack JSON body. However, if you are using Java 8, it comes with the lambda DSL JSON expressions, and that is even more readable and much better way of writing these things. But essentially, that's how we go ahead and create our different interactions. Now, the second part is writing the consumer test. So if we see here, we just use that test annotation, which is a JUnit test. And we are saying the pack test for, and here we are saying the pack method articles. So it will be ensuring that this specific method is actually executed when this test is executed. So as I was telling, that verify fact a pact is basically a step that ensures that all your interactions are executed. So this one will ensure that this specific test executes this interaction. So you might write this interaction and your test might not include this specific interaction. The test, however, passes, but your pact verification will fail and sail, and it will start complaining that your interaction was never executed. So moving on to the next page, which is the again next it is the publishing to the pact broker and writing the provider tests. Tests are the other two things. Now, if we are using Spring Boot, we have the Maven plugin and the pact JVM provider Maven plugin. Then you can use your version, and if you'll configure your pact broker with the hosted URL, the pact directory where your pacts are getting stored locally, the project version, and all these configurations. And then you can use the Maven pact publish command to publish all the packs from your local to the pact broker. So it publishes the packs over a HTTP request. And when it is published to the pact broker, now on the provider side, if you are trying to run your tests, this thing is just writing this test template, and all you need to do is you need to mention the pact broker. And if you are injecting the pact the Spring context inside your pact Spring context, you can mention your broker host and your authentication for user and the password. So with this one, it will automatically go ahead and take all the different uh, consumer contracts that are available in the pact broker, and then it's going to pick those and run again the provider code. So that's how it works in Spring Boot Java world. The next is the JavaScript one. So the JavaScript one is also very similar to the Java Spring Boot one. So here also we are defining the interactions. So here, as you can see, these interactions are like the similar one. The state upon receiving the request will respond with a specific structure and the status and the headers. And this is a consumer test specifically written over here. And this is a packed setup that where specifically the mock server is going to run. Now, on publishing the pact is again here you get a publisher, and with the publisher you can publish your pacts to the pact broker. On the provider side, there is a verifier, and with the ops you can do all these verifications of the provider side as well. So all these things are the code snippets that I have taken from the pact documentation. There is a very thorough documentation in pact, and you can go ahead and find a lot of examples over there. And what I wanted to highlight here is that the steps or the basic process still remains the same. It's just the essence of the different programming languages. And when you start introducing the different programming languages, it's still the same discipline. It's still the same testing process. However, it's native to your own programming language and doing the things. Now, moving on to my last part of the discussion, which is how we can do a continuous testing and how we can deploy with confidence without breaking any specific environment. Because most of the time we see a problem with the microservices that we deploy to a certain environment and we don't know which all we are breaking. And the communication is always a problem in a large enterprise with lots of teams and a lot of people coming in and working together. So it's better if we can automate those processes and bring in a lot of automation into it. This here, let me just so this here is a representation of an indicative representation of contract testing integration in CI/CD, how it might work. So this is the first part is basically on a pull request. there is a pipeline that gets triggered. There's a continuous integration pipeline that runs the unit tests, followed by the different test phases that you have. You might have your component tests, you might have your integration tests. Uh, then the different contract tests might come into picture here. The consumer contract tests and the provider contract tests. So if it is both a provider and a consumer, it should run both. Otherwise, it will be the one of the things. Like most of the cases, it would be only provider if it is not consuming any service. But other than that, it will be both the provider contract tests and the consumer contract tests. So as soon as this gets executed, and everything looks green. After that, you might have a lot of other phases like your static code analysis, code quality checks, or even you can have a manual intervention here before merging the code. You want to go ahead and do a manual code review before you merge your code. So whatever might be the process, and once when everything goes green, then we go for a code merge. Now, as soon as the code merge happens, automatically it again triggers two things. One is publishing the verification results and publishing the pack brokers. So when the provider contract tests were executed, there was set of verification results that got published, so or that got generated. Now you need to publish it back to the pack broker, because if we do not do this step, then we don't know what is the verification result of that provider contracts. And at some point in time, if we are trying to deploy and we want to see the compatibility, we cannot find it on the provider side itself. So publishing the provider verification results is a very important step. And if it is a consumer as well to certain microservices, then the consumer contract tests are required, are executed. And if everything is green, then you get pact generated, and that pact needs to get published to the pact broker. Now here the webhook plays the important role. Now, as soon as the pact is published, it's successful, the webhook can trigger a pipeline from the pact broker for the provider pipeline verification. So when a specific consumer publishes the contract, a new contract is generated for a specific provider, and the provider verifications are triggered. Now, all the provider tests will automatically get executed along with that. The next one is if after that all these things, everything is green and everything is going fine, at this point in time we can still use the can I deploy before deploying. And here the can I deploy can make sure that for a specific provider, if there are 100 different consumers, all the consumers are compatible, and actually the provider consumer compatibility is working fine. And if everything is green, then we can go ahead and push the change to the specific environment. And if it is not, or if it is a consumer of a service, then it can still go ahead and check whether that specific, for that specific consumer, if it is a consumer of 5 different services, all the providers are compatible with this consumer service, then only we can promote this consumer service to a specific environment. Otherwise, the can I deploy says that we cannot go ahead and deploy, and we are not going to deploy. And if it's all green, then we go ahead and deploy. Followed by it could be a system integration test in an integration environment, or when the integration tests are executed. After that, you might again want to promote to a new environment. And while promoting to the new environment, you can still go ahead and do a can I deploy for validating that that specific contract is valid against the environment. Now, Pact also provides something which is called the tags, and the tagging can play a very important role in promotions from a specific environment. Like as soon as you promote your compatible, now when you go deployment, as soon as the deployment happens, you add one more tag, which is the test. And every time you can go for a compatibility at the tag level as well. And that tag level compatibility will give you or ensure that all your environments or all your participating microservices are working properly from one environment to the other. Although it doesn't eliminate the need of the integration testing or the UI testing, it's still you need to do a certain level of it, not at a huge level, but to some extent you still need to do some level of integration testing. But definitely it reduces a lot of testing effort, lot of integration testing effort from our end. That's pretty much it, and I would like to show briefly on the Pact Broker instance that is running on local. Uh, but before I go into that, if you have any questions, feel free to ask.
Yeah, sure. Thank you for the covering this topic. It's very interesting, and I think nowadays, as many teams are building like small services, and everything is more or less about service deployments with different types of languages, it becoming more and more uh, demanding to have such kind of tests. And from my perspective, the question is, for example, let's say we have a simple project. It consists of backend written in any language, let's say Java, and it has front end that it uses API, REST-like API for interacting with this backend. How can Pact help to bring this consistency between backend API and this backend will be provider and with front end as consumer? How you can like suggest to start? For example, we have this kind of project. What should we do to start with Pact?
One thing I can say, and then what I haven't used really, and I do not have any hands-on experience with that one, but I read and in many blogs, and I also saw into their documentation. Now Pact has support for the Cypress, so you can, if you're writing your UI automations using the Cypress, you can still write. So here, the example that you gave, the front end is basically a consumer, while my backend is basically a provider. So it's still a provider-consumer interaction that happens. And on the consumer side, which is my front end, if we are using Cypress for our test automation, it also allows you to define the interactions, and it also allows you to write your packed tests and along with the Cypress. So in that case, you are still running your UI automation tests, but your packs are getting executed. And then on the provider side, you can have your pack provider in, tests written, or you can get from the pack broker and execute all the tests. That's one way of doing it. And apart from that, if we are not doing it in that way, better something could be like on itself, we could write some of the tests, uh, which could be just specifically dealing with the interactions. Those are extra set of tests which are not specifically a UI test, but maybe on the UI layer, we might write a certain tests where the calls are happening. And in those calls, we might define all the interactions, and that might go back to the pack, published back to the pack broker. And from the pack broker, the provider side or my backend can go back and get all this information. These are the two things that I can think of on top of my head.
Okay, thank you very much for the answer. Is there any other questions, guys? You can just unmute yourself and ask it
Oh,
from the spot.
hello, Abhi.
Hi.
I have question. What I see in practice sometimes when we test several services, microservices, and they are like already verified and compatible with each other. In practice, when they deploy production, very often we use some kind of API gateways like Kong or Nginx or something else. And like this is intermediate layer between these microservices. And when something is happening, we get response not directly when we call microservice, actually we get response from this intermediate layer, from like something not happening according to our expectation. We got error from this intermediate layer. Can we do something with contract testing to like mitigate this?
I'm not sure if contract testing would feed in such scenarios. It's more around, if I understood correctly, it's more around the infrastructure, and something happens within the infrastructure itself, and the network plays a very important role there. So I can share. We also faced a lot of issues with infrastructure, as you mentioned that uh, the Nginx layer or some other layers in the network might cause a lot of trouble, but I'm not too sure if contract testing would help us with that one. Contract testing deals more with the functional aspects. It's more around the microservices behavior. This kind of things might be more suited for something like a chaos testing or a chaos engineering, which might give us some value to it. But I am not too sure that if contract testing would add a lot of value to it.
I see. Thank you.
Thanks.
I have no questions.
Any other question? Or I will just give you a brief demo of the pact broker that's on my screen.
Yeah, I think if no one is willing to ask you, you can continue with demo. Thank you.
All right, so this is how the pact broker looks like. So there is a consumer and the provider, and there's example app and example API. And if you see that it also shows that pact, when the pact got published and when it was last verified, if it is showing green, that means it is successful. If I click on these details, it actually shows all the different and the different interaction that gets validated upon. Similarly, this grid is very important, which actually shows all the different consumer version and the provider version, the tests that has happened over the past and the different compatibility over the things. So these are kind of things that adds a lot of value when we are testing or we are trying to do a seamless deployment to a specific environment for large set of microservices. There are some of the very important things which we get to see, like this kind of a network diagram, which I personally really like it, and I find it really useful. That here it shows the outbound dependency that example app is using consuming example API. So if there are 5 different microservices which are consuming the example API, you will see all the incoming arrows. And if it is a consumer to something else, then you get an outgoing arrow from this one. So in that way, this essentially becomes the entire network diagram of your microservice architecture if you are doing it in the right way and everyone is participating in this entire thing. Few things just before we close. My suggestions or my observations so far with working with the pact is that the pact works well when everyone is participating. That is, all provider and consumers are compatible to pact. So if something that is not compliant to this framework is not lying within this one, it might not work properly. And the second thing is mm, so yeah, and at times the consumer driven contracts become testing becomes very complicated on the provider side because test data creation gets complicated. So test data creation is something that there is something called a provider state injection, which allows you to create the test data on the provider side, but that controlling a huge for example, there is a provider service that has 50 different consumers. Maintaining your different test data becomes really complicated on the provider side, and that requires some amount of contribution from the consumer to the provider. So those are some of the things that you need to keep in mind while you are choosing your tool stack or while you are writing your tests. There is a very recent topic that has grown more popularity is the provider-driven contract testing approach. I have done a little exploration around that one. I see a lot of promise around it. That in itself is a huge topic. Might be we can discuss some other day, but that's something which might help, which is more of a schema-based validation between two different contracts, and that doesn't go and goes into the code level for validating the test. That adds a lot of values, but it has its own cons too. So these are the few points from my end. Over to you, Anton.
Uh, Thank you very much for your slides and showing the diagram how ideally it should be placed in CI/CD environment. I have several questions regarding the integration. So as far as understood, the contract itself lives inside the pact that should be published somewhere, and this place like is behaving like centralized repository of pacts, right? Are there any challenges if you maintain this pact broker for different environments, for different teams? Uh, did you see from your experience like problem? Let's say if you maintain 10 projects, it's more or less obvious how to do it. If it would say we have 100 projects, we may face some different obstacles.
Yeah, I mean, if managing the different pack broker for different projects, if those are completely independent of each other, then it absolutely makes sense, because maybe we have three different application which are the microservice architectures, but I'm not too sure if it will work properly if all the 100 different teams are working inside the same architecture and contributing to some way or the other with each other, because in that case it doesn't allow you to collaborate with the different feature teams and restricts you to your own project team. So those are the pros and the cons, and maintaining it for the different environments, it's complicated, because if we are not making the consistency over the environments, we might not be able to see the gradual progression of our test data from one environment to the other, and and how it is behaving into the different environments. So maybe it's wiser to use one single pact broker for all the environments for the projects. If it is non-interacting projects with the separate different projects, obviously it's wiser to use separate pact broker. But if it is the same project, we should be going for a single pact broker. Having said that, if it is a microservice that has huge number of consumers, like something which is a public service, like a Google's own API, in that case, we do not have any control over the huge number of consumers coming in. So in that case, the consumer-driven contracts are something that might not work really well. So that always has been and which we find as a challenge, but that challenge needs to be addressed. Communication gaps and communicating with the people. So yeah, automation helps you to identify the things, but still the people need to talk, the teams need to talk and understand what is happening.
I saw on the latest picture you showed there is like status of webhook. What does it mean, status create? If it's possible, can you go back to the latest picture you showed?
You mean in my presentation?
In your demo, like there is a small table and it shows like webhook has status create. Yes, webhook status create. What does it mean? Yeah, yeah. Back the page. Yes, webhook status.
Uh,
What does it mean?
So it's like what are the different way? So we can, as I had mentioned here, that we can create different types of webhooks for a specific packed sets, or this specific is on the create. So as soon as so if I click on this one, so it takes you here. So, there. So which I understand is this specific one talks about that this whenever a new pact gets created, a pipeline gets triggered or something like that. So that's
Mm-hmm.
the webhook status. I am not too sure about this one though, because I use the pact flow version of it.
Mm-hmm.
I didn't use the pact broker, the open one. That one looks a little different from this one.
And what is your experience with integrating this pact-based test to CI? Did you use some, like, what tools did you use? Is it Jenkins or any other tool?
We use Jenkins. We use Jenkins for integrating it to the CI pipelines, but you can use anything. In the documentation of PACT, you will find the support for a lot of the CI tools. It has the support for Jenkins. It has support for GitLabs. It also has support for Travis CI and several others as
Mm-hmm.
well. So
Okay,
it's really
got it.
simple to integrate with anything.
You mentioned that you moved from open source version of Pact to paid one, right?
Yep.
And uh, like, what was the intention to make this move? What they provide for you as a, like, tester or developer? Does it make
So
sense for
one of
anybody, or it's just if you have many projects, like, what the benefits?
one of the biggest reason, there were a couple of reasons why we moved to the paid enterprise version from the open source version. So the first and the one of the primary reason was that the infrastructure management in house was becoming complicated. So it's a software hosted as a service. It's a software as a service. So infrastructure maintenance remains with the packed team. So the developers. So we don't really care about its availability and stuff like that. So that kind of maintenance and infrastructure maintenance, which is not the core competency that we are trying to build, that was one of the things that was outsourced or moved out of what we were doing. That was one of the biggest reason why we thought of going for Packflow. The second thing was more around one of the features that Pact has very recently come up with and they're working on. We looked into their backlogs and we found some support provider driven contract testings and the validations with the provider driven way, which is a schema comparison way, because as I was mentioning that the consumer tests and specifically validating the test data becomes complicated when you have too many consumers. And we had certain scenarios where we had a lot of consumers and it was not getting easy to do the consumer driven way. So we started looking or exploring towards the provider driven way, and Packflow came up with certain features which we found promising. And that's when we started looking towards it.
And with what kind of polyglot environment do you have in your, like, company or projects? As far as I understood, it's Java, JavaScript. What other languages do you use with Spec?
So initially, it was all Java, and then it was Java and JavaScript, Node.js. So, but the plan was more in introducing more programming languages like Kotlin. There was discussions of introducing languages like Swift and Go, uh, and those were the programming languages. And also .NET was being discussed to bring in. So essentially, when we were evaluating the tool and when we were going from Spring Cloud Contract to this one, we started looking for the languages that were prioritized, and those prioritized languages included .NET. It was Java, It was JavaScript, it was Python, and it was Swift. And we found that PACT supports all these different programming languages. So that's one of the clear edge that we had got, that we could get the PACT.
Let's say if we have a company that is already using Spring Contract in like more or less Java-centric world, do they have any like not possibility but any reason to check the pact, or they are fine with uh, Java version, and if you are using Java, just stay with it and even don't try pact? What do you think? Is there any reason to switch from Java
One of the primary difference
Spring
Spring Cloud
contract
contract
yes, yes.
To PACT? Yeah, I think one of the things that I personally felt was more promising and more convincing for me with the PACT was PACT. In PACT, by philosophy, you write the test and the contract is auto-generated. But in case of a Spring Cloud contract, the contract is manually written and the stubs are automatically generated. There is no foolproof way of validating that all your interactions are validated against the consumer contract, which is the biggest advantage that PACT gives. And it actually ensures from the both way that your provider and on the consumer side, whatever you are writing, whatever is going into the PACT is tested both against the provider as well as the consumer. It's much stricter in nature. It has chances of lesser loopholes or missing something, which in case of Spring Cloud contract is by philosophy was initially not more of a consumer-driven approach, although it can be used in a consumer-driven way, but it's not essentially a consumer-driven approach, and that's where I found that this could come or or PACT gets a little edge over Spring Cloud contract. But having said that, end of the day, it's the tool set that suits the people. It's the tool set that suits the organization, and that's what one should be going for. So I think the good observability is a key thing that we have we can measure anything via Spring Cloud contract. There is a possibility of missing a lot of things. Are we missing anything? If not, it's better to stay Spring, because Spring does a lot of magic within itself, reduces a lot of effort, of coding effort, but then it poses certain risks, and we need.
Sorry, something was interrupted. Abhi, can you hear us?
Yeah. I don't know. I got disconnected for some reason.
Okay. Yeah, I got your answer. Understood. Thank you very much. So, if we don't have any other questions, I'd like again to say thank you to Devendra and Abhi. There were wonderful topics described today. I really enjoyed, and I'd like to say thank you for everyone who joined our meetup today, because it's still Saturday. We can spend this time other way, but you choose to join Ministry of Testing meetup. I appreciate it. So if you want to share your knowledge, your experience next time, just drop me a message and we will arrange it. Once again, thank you everyone.